Okay, go ahead and respond to the online attendance poll for extra credit. Also, I need to address something. A student in another class pointed this out to me, and there have been some news and information going around about DataCamp and their inadequate response to an incident of sexual assault, and and so I've made the decision that I will not. We won't use DataCamp for the class anymore. Okay, this was this is disappointing for me because I believe that the product that DataCamp offers is an excellent product. The training that they do offer, the materials and all of those resources, I think are excellent. But after reading kind of DataCamp's public statement and also other people's I guess thoughts and feelings on the issue, I cannot in good conscience require you as students to use their service. So I've shared a few links in an announcement to the class, and so this will. So I had structured a lot of the course around using the DataCamp homework and all of that, and I made the DataCamp homework 30% of your grade, and so I decided to just grant free points for that portion of your grade. I know that's, for me, that feels a little bit drastic, but I feel like that's kind of the fairest move that I could do for you guys as students. I don't think it would be fair to just suddenly restructure the grading of the class. So that's what I've decided to do. I've got my homework cut out for me in that I need to start writing a bunch of my own homework assignments. I was kind of counting on DataCamp's assignments to supplement the ones that I was planning on giving, but I'll probably have to write some things up. So just I ask for your patience there. And I was never one to kind of impose my opinions and thoughts on others, and so I encourage you to inform yourself, read kind of the statement that DataCamp put out, read the articles that other people have written or the blog posts that other people have written, and you can come to your own decision regarding whether or not you want to use their services or not. As far as your accounts and whatnot, DataCamp did grant kind of premium access to all students for 6 months, and so you still have access to that, and that's not going to be taken away by my decision to no longer use their service for the class. Anyway, I leave that to you. But if you want my kind of full opinions and thoughts, you can feel free to talk to me during office hours and whatnot. But I've this is the decision I've made for the class. I don't know if you had any questions regarding that. Okay. In week 3. I have put up a few links here, okay? So this first one is your group sign-up sheet, okay? And so this is just a Google sheet. You're gonna just go there and put in your group information name, okay? So you should have 4 students to a group, and I think I've given one group permission to have 5, and I will expect a little bit more. I think if you have 5 people in your group, but this is basically you'll put in your group name, your group repository, and then put in all of your information, your name and your repository things. And if you're currently at a place where you have only like 2 group members and you're looking for more, you can go ahead and put in that you're looking for additional group members. Okay, and that should be that. There's also 2 other spots here, links to sign up, and one is during 6th week. Each group will come to me and make we'll have a 15-minute discussion, and this will be kind of a project proposal. You'll tell me what data set you're going to work on, and I guess what you're thinking of doing and what kind of an analysis that you want to explore there. And I'll just give you some initial feedback as to whether or not I think this is, I'll just ask some basic questions where just to make sure that you understand the data, okay? Because what I don't want to happen is students to, and I'll give kind of full details of the project later, but what I don't want is I don't want students doing analyses on projects or on data sets about which they have no knowledge or understanding. So, the first time I did this, there's a popular data set on Kaggle about like wine and stuff like that. And like it talks about like acidity and types of wine and things like that. And I don't know about you, but I doubt that we have many wine experts in the classroom. And it's just the analysis you can do if you don't know anything about wine, other than it comes in red or white, is going to be limited, right? And if you're going to say like, oh, we can do statistical analysis and tell the difference between red and white wine, that's true, but I can also tell the difference between red and white wine when you pour it, and that's not going to be an interesting thing. And if you don't know the difference between like a Zinfandel and a Merlot and a Cabernet, you shouldn't be analyzing probably the wine data set. So anyway, during the 6th week, I'm going to just ask what's the data set that you're planning on working on, and I'll ask you a few questions to make sure that you have some knowledge about the data. And it might only be that one person in your data group knows about this subject, okay? It might be like one person's like super into rugby, and this is, you're going to be doing a rugby data set analysis. That's fine. As long as there's one person in your group that is knowledgeable on the subject, that's fine. But I need to see that, okay? There was another group, in an earlier quarter where they found this data set taken from like some news website, and they were going to look at headlines, and it came from ABC News. And so I just started asking a few questions, and it became very clear to me that the group had no understanding of the data, because the ABC News, the A there was stood for Australia, and so all of the news headlines were related to Australian things, and the group didn't realize this until like I actually took a look at the data set, and I'm like, why is Australia showing up so often? Anyway, we're just going to schedule a quick 15-minute kind of session. I'll just make sure that you're doing something reasonable. And then during the 10th week is when you're going to do your final project presentations, okay? And those presentations will be 45 minutes long, and you'll probably present around 5 minutes, and I will spend the remaining 40 minutes basically asking you to defend all of the decisions that you made in your analysis. And I'll probably go through and I'll ask each group member what they contributed to the group, okay? Just because what I don't want is I don't want one person carrying the great burden of the presentation. So I want to make sure that every group member contributed to the group, and probably what I'll ask is, what did you contribute? And please explain your portion of the report. And that should discourage people from slacking off, I guess, because I know that's a great. Nobody enjoys group projects per se, but they are also a fact of life wherever you go. You're going to have to work with other people. So anyway, sign up for this. The schedule things, those are just kind of first come, first serve. So once you and your team members can agree upon a time to meet, put that in there, okay? And then, honor code. If another group already claimed the thing, don't delete them and put yourself in their appointments spot, okay? It can be edited by all, but please be kind, okay? All right, any questions on that stuff? A full detailed list of kind of how the project's gonna work and grading criteria will come later. Okay, then we'll get started on today's content, where I will introduce Numpy. Okay, so let me magnify this. Okay. All right, so to get Numpy into your thing, I think when you install Anaconda or whatever, Numpy is already installed, but you can always do a conda install Numpy or conda update Numpy, all of that. And then when you start up your notebook, you'll want to run import Numpy as np, okay? And this is just in order to use. So when you start up Python, it doesn't automatically load Numpy, and so you can't use any of Numpy's stuff. And so you have to call an import Numpy. But to make use of Numpy, if you just called import Numpy, you have to type out Numpy every single time. And so just to kind of abbreviate it, everybody has agreed that NP is the abbreviation for Numpy. And so that's what we'll do. You can just kind of see which version of Numpy you have, and I think this is the latest version. Your software is always kind of being updated by people out there, and so if you have an older version, you should probably update. But yeah, you can be creative and call import Numpy as something else, but you're going to confuse other people when they read your code. Okay, we're all kind of expecting NP. Okay. So the key structure in Numpy is the array, all right? So we spent a lot of time talking about lists, because that's a base structure in base Python, and lists can handle different kinds of data. And Numpy is kind of like the atomic array or atomic vector in R, in that everything in that's a Numpy array has to be the same data type. You cannot mix integers and floating point things, or you can't mix characters and numbers and things like that. And so you create it by writing np.array, okay, or numpy.array, np.array, and then inside that you put whatever it is that you want to turn into array. So here I'm going to turn np, the list 1, 2, 3, into a Numpy array. And when you do that, it looks like this, okay? When you create, and you'll know it's an array because it'll say array, when you ask Numpy to print, or Python to print, the array looks like this, okay? All right, and so, whereas when you print a list, it looks like this, okay? So there's just subtle differences, but you'll know that you have a list because there's commas between here, and you'll know it's an array because there's no commas. between the values, okay? Or that's when you call print on it, and if you just have it being output, it will say array, okay? So it'll say array here, and this is how you know it's an array. Or when you call print, there's no commas between there. So subtle differences, but there are differences. You can look at this output and know it's a list, and you can look at this output and know it's an array. Okay, and when you ask what is the type of the array, it's going to say it's a Numpy ND array, ND for like n-dimensional. And so here, if you give it an array with, give it a list with mixed data types, and you throw that into an array, Python, they don't call it coercing, they call it upcast, okay? So that's the verb that they use, but it's the same idea of coercing. It's going to turn it into a thing. And so what will this become? So 3.0 is a float, okay? So everything's going to get upcast to a float. So you're going to get 1.0, 2.0, 3.0. False is going to be 0.0, and true will be 1.0, okay? Or I guess just the dots to indicate that they're floats. Okay. And again, here I've got a character, okay, or string. And so if I upcast this, everything turns into strings. Okay. 1, 2, 3, true and false. Okay. Here, if you give it a list of lists, okay, so I've got the list 1, 2, 3, and the list 4, 5, 6 inside another list. So it's a list of 2 lists. And I throw that into the NumPy array thing. This will create a matrix, okay? They call this a multi-dimensional array, and it looks like this, okay? And we can tell it's multi-dimensional because this part, there's 2 opening square brackets, okay? We got square bracket, 1, 2, 3, and then there's 2 closing square brackets, okay? So it's like kind of a vector up there and a vector down here, forming the array, okay? Now, if you try to do this, where the dimensions don't match, you get an array of lists, okay? Which is probably not what you want, okay? But if you give it something where the dimensions match up, NumPy will figure it out and make basically a matrix out of it. Okay. Quick ways, if you want to make arrays really quickly, you can call zeros, and this will make a floating point zeros array, okay? And here, if you want integers instead of floating points, you can say data type dtype is equal to int, and it will do that. If you want, you can make a matrix with dimensions 2 by 4, okay? So here, basically, you're calling np.zeros and you're giving it a dimension, okay? And so if you only give it 1, it's going to create a 1-dimensional array. And if you give it a dimension 2 by 4, it's going to make a 2 by 4 array, all right? So this is what we get. And then here is 2 by 3 by 4. So this is going to create a 3-dimensional array. And so you get, I guess, a 3 by 4, and you have 2 sheets of 3 by 4. Okay, so you have this prism. Okay, and then if I do, so 2 sheets of 3 rows by 4 columns, and if I do this, 2, 3, 4, 5, so now I'm going to make a 4-dimensional array, and so I'll have like 2 blocks. Each block is going to have 3 sheets. Each sheet has 4 rows and 5 columns. So it's a little bit hard to see, but I've got block 1 up there, and here's our second block. And you can kind of see based on kind of the leading opening brackets, okay? So this is the end of 1 block. Each block has 3 sheets. Each sheet has 4 rows, and each one has 5 columns, okay? All right. And then the counter, or the counterpart to zeros is ones. You can do np.ones, and it will create things with ones, okay? And then you also have np.full, which basically does the same thing, but you get to select an arbitrary value. If it's not 0 or if it's not 1 and you want something else, you can say np full 2, 3. I want 2 rows and 3 columns, and fill this in with the number 1.2. Okay, so you can fill out the matrix or fill out the array accordingly. If you want to generate random numbers, okay, you can use np.random, okay, np.random, and then within random there's different functions, okay, so numpy random.c. Anytime you see any of this stuff, np, and any function name, there's going to be tons of documentation out there, okay? So you can always just look up numpy random, okay? And this will probably pull up just a whole bunch of stuff. So this is random.random. Okay, yeah, here's numpy.random, and it just kind of lists off all of the different functions that exist within random, okay? So I'm just focusing in on a few of these things, probably the ones that you'll use most often. Okay, so one is you can set the seed for reproducibility, which is, you know, what we often like to do. Random.random will generate numbers from random uniform, so between 0 and 1, okay? And so, see here I've got, you know, 0.417, 0.72, 0.114, things like that. Oh, I'm sorry, this one's 0.000114, okay? It just generates numbers between 0 and 1. This is a random uniform, okay? rand_n will generate numbers from the standard normal, okay? And this will produce 5 numbers from standard normal, so we're getting, you know, values between basically 3 and -3, but distributed normally, okay? And again, all of this stuff, simple. So rand will do that, and then where's rand_n? Oh, rand_n, yeah, standard normal. Okay, rand and rand_n, just kind of your simple things. If you want something that's more complex, you can do any of that stuff. So here, we're going to say I want values from random normal, I want mean 10, standard deviation 3, and I want them arranged in a 2x4 matrix. Okay, and so there you go. Random integers, we'll say go from 0 inclusive to 10 exclusive, so digits 0 through 9, and we want 20 of these things, so it's going to do that. And if you want to simulate die rolls, you would go from 1 through 6, okay? But because the last one is exclusive, you're going to write 1,7, so this is 50, rolling the die 50 times. Okay. So here, and then there, you know, there's a lot more stuff. You can generate values. I think I just showed from the normal distribution. Okay, so this will be location, scale, and size. Those are the arguments that it accepts. But if you want to generate values from any other of these random things, so beta distribution, binomial, chi-square, exponential, all of these other ones that I've completely forgotten about. A von Mises distribution, I don't even know what that is. Something, okay? You can do this, all right? So those are all options via Numpy, right? So you have to kind of call Numpy for these things. Okay, the other thing is making sequences. And so we've already covered creating ranges in Python, and NumPy has an equivalent statement called NumPy arange, okay, array range. All right, so and it works pretty much the same way as range in Python. So 0, 10, step size 2 returns a range 0, 10, step size 2 object. And so if I throw this into a list, what will this create? It will create a list of values that start at 0, 2, 4, 6, 8. And does it stop at 8 or does it go to 10? Stops at 8, yeah? Okay, so that's the list. Same thing if we call an NP arange 0, 2, 10, 0, 10, 2, except now it's in an array. You can also create the range yourself and then throw it into an array. And it will return the exact same result. But probably it's easier just to call the arange command on from NumPy. Okay, arange 0, 105 will go from 0 to 95, and then and if you're gonna just have step size 1 and start at 0, then you can just do arange 20, and that will go 0 to 19. Okay, so by default the start is 0, and by default the step size is 1. So if you just need 0 through 19, you can just call arange 20. Okay, and that will work for using as indices for an object of length 20. Okay, because we're at 0 index language. All right, and then linspace will create a linearly spaced array. Okay, so it starts at the start, it ends at the end, and the number of outputs will be the length is given here, and the end is inclusive. Okay, so that's one thing that you have to kind of get used to. So 0, 111 will go count up by tens up through 100. Okay, because if you count by tens, then from 0 to 100 you're going to have 11 objects. Whereas if you did 0, 110, then it counts by 1/9, right? Or I guess 10/9 or whatever. So 11.1 to 22.2, all the way up to 88.8 and 100. Okay, because the output length is 10. If you want to avoid this, you can do endpoint is equal to false. Okay. And then it will count from 0 to 90, all right? And over here, but if you did 0, 109, endpoint equals false, it's going to look like this, okay? It's going to look like this array, but without the last one. So using endpoint equals false ends up actually being a tiny bit confusing, because it's like, it's making the way it calculates the linear spacing is basically doing 0, 100, and then 10, and then after doing that, it drops the last value. Okay, and so I think it's a little bit, I don't know about confusing, but maybe you have to think a little bit more than setting endpoint equals false. But that's one thing that you have to become accustomed to, is that the regular range object does not include the endpoint, whereas linear space will include the endpoint. Okay, and so you'll set up your arrays that way. Okay, if you want attributes of the array, such as the number of dimensions or its shape or the data type, probably the shape is probably the one that we use the most frequently. You just type in the name of the array, okay, and then you do dot shape or dot whatever it is. Okay, so here I'm creating an array of using np1s 3 comma 4. So what is this going to produce?
3 by 4 line.
Yeah, so it's going to create a 3 by 4 array, 3 rows, 4 columns, all ones. Okay, so this is what we have. All right, and so x.ndim, what will this return? Number of dimensions. It's going to return 2. Okay, you've got 2 dimensions. All right, x.shape will return 3 by 4. Okay, it's going to return a tuple that says 3, 4. Okay, 3 comma 4. Number of rows, number of columns. Okay, and then the x.dtype will be what? It's going to tell you the data type stored inside there, so it's going to say it's a float. Okay, 64-bit float, which is kind of our default numeric data type. Okay, this is the equivalent of type data type double in R. Okay, because the array is filled with 1 dot. Okay, 1 dot, 1 dot, meaning each of these values are floats. Okay, if I said data type is integers, then it's going to create integers and data type here. Okay, so here if I do np arrange 0, 12, 1, this will produce what? The array will be 0 through 11. Okay, number of dimensions? 1. Okay, and then the shape? It'll be 12. Okay, it's a tuple that it's going to come out 12 comma nothing. Okay, so it comes out as a 1-dimensional array. So if I asked what this is a tuple with a single dimension. Okay, so it's just saying there's length 12. There's no second dimension here. Okay, so so I think, you know, as far as I go, array.shape is probably the most frequent attribute that I ask for. But you know, I guess dtype and ndim, that they exist as well. Okay, and now we can start talking methods. So methods are functions. So notice that all of these things, because they're attributes, I just type in x.shape and I don't use parentheses, right? So these are attributes, whereas down here, these are methods. Okay, so I do np.arrange and I have a parentheses to indicate that this is a function that's being called. Okay, or I'm sorry, this is not this. Reshape. Reshape has parentheses to indicate that it's a function being called. So here I'm going to create a 1-dimensional array, j. Okay, so if I said np.shape on this thing, we're going to see this basically, 12 comma. And then I can call the method reshape. Okay, so I can call the reshape command and insert j here and reshape it to have dimensions 3 by 4. Okay, and so when I do this and I store it as k will be a 3 by 4 matrix. Okay, and it goes this way. So an important thing is that when we reshape it, Python will fill it out row-wise, which is the opposite behavior of what we might be accustomed to when we reshape something in R. Okay, so we have this, and when you call it this way, j is left unchanged. Okay. However, if you call j's method reshape, and you say reshape 4 comma 3, meaning make it 4 rows and 3 columns, it will do this. I'm sorry. So this will return a copy of j, and the original j is unchanged as well. Okay, and again, all of this you can do np. I'll do array reshape. Okay. So this is the ND array reshape and Numpy reshape. So this will this kind of gives the full reference. You call it on the A and all of this, and so this tells you basically an int or tuple of integers regarding how it should be reshaped, and what it will return is the reshaped array. Okay, so here we go. And so, we've created K to be this thing. K.T, capital T, is the transpose. So, so you can create transposes this way. Okay. And calling calling transpose does not modify the original thing, so K is still a 3x4, whereas K.T is going to be the transpose. Okay. And so all of these things, you can kind of chain the methods together. And so here I can create a range, 0, 12, comma 1. So that's going to go 0 through 11, length 12. Reshape it to 3x4, and then I call the transpose on that. What will this produce? The dimensions will be what? 4x3, and then I'll have a 0, and then where will 0 will be in the top left, and where will 1 be? Will 1 be to the right, or 1 will be below? 1 will go below, right? Okay. So we're just kind of chaining these methods together. All right. Why is I'm gonna just create a thing. If I call the shape, I get 12 comma. If I transpose this, okay, so this might feel a little bit strange, but this is a one-dimensional array, so if I transpose it, it's going to end up actually being exactly the same. And if you say, what's the shape, it returns back still 12 comma, because when it's one-dimensional, there's no dimensions to switch around, okay? It's different from the way R handles matrices, okay? So just these are some habits that you gotta kind of break and get accustomed to with the way Python handles these things, okay? So a one-dimensional array cannot be transposed. It remains a one-dimensional thing. What you can do, however, is that you can reshape this thing to be 1 row, 12 columns, okay? And they look very similar, but now we know that it's two-dimensional, okay, that it has 1 row and 12 columns because there's 2 square brackets on the end. Whereas here there's only 1 square bracket, indicating that there's only 1 dimension that exists. But now that there's 2 square brackets, it indicates that this is a two-dimensional array, okay? I've got 1 row and 12 columns, and if I ask for the shape here, then it will say it's 1 by 12. It's a subtle difference, but it impacts the way Numpy handles these things, okay? So now I can call transpose on this thing, which is a 1 by 12 array, and it will return a 12 by 1, okay? And then the shape of this will be 12 by 1. Is that all right? The difference between what happened up here and what happened down here. All right. I think for people coming from R, the idea of having truly a one-dimensional array is probably the most foreign thing to deal with. Okay, because we're used to having kind of vectors and stuff, but then I think in our brain we're thinking of this as like 1 row and 12 columns or something. But this is truly a one-dimensional thing, and so that you can't transpose it. Okay, let's talk about subsetting and slicing. It's just like slicing lists. So here is this. What will y square bracket 4 return? Will that return 3 or will that return 4? It returns 4, right? Because it's 0 indexed. So if I want 0, I would put in y square bracket 0. And if I want 4, I put in y square bracket 4. Okay. Okay. The shape of y is 12, and so it's one-dimensional. 4:6, what will this return? 4 and 5. Yeah? Okay. You can slice like this, 1:8:3, and that will be start, stop, step. Okay. So what will this return? One, 4, 7, 1, 4, 1, 4, 7, 10. 1, 4, 7, yeah. If I did this 1, 7, 3, then that ends at 1, 4. Okay, it's the stop is exclusive here. Okay, and you can leave off if you leave off a colon, then it'll assume 0. Okay. So here, if I did NP arrange 100, and then we're going to subset that with colon 100 colon 2. So it's going to basically say start at 0, go up to 100, but don't include 100, and go with a step size of 2. So that's going to go 2468 up to 98. I'm sorry, starting at 0, 02468 up to 98. Okay, same thing with a higher dimensional array. All right, so here I'm going to take y, which is 0 through 11, or our a range 12, reshape it to 3 by 4, and we get this. Okay, all right. So what will square bracket 1, 2 return? So this will say we want row 1, column 2, but we're 0 indexed. So this will return 6, okay? Because this is the first top row is row 0, row 1, row index 2, column 0, column index 1, column index 2. So 1, 2 is this value 6. Okay? And if you subset this, this is just the integer 6, okay? It's not an array, right? But if I ask for 0 colon 2 and 0 colon 2, what will this return? So if I slice this, this will return what are the dimensions going to be? 2 by 2, so it'll be what, that 0, 1, 4, 5, right? And this will be an array, okay? And if it's not clear that this is an array, so we have that. Here, using a colon with nothing around it will do what? It will do everything, okay? And so so this will give me row index 2, which will basically just be 8 through 11. Okay. And then if I ask the shape here, this is one-dimensional. Okay. So so there's a little bit of reduction there. Here's the column. If you do colon, comma 2, and this shape again is also one-dimensional with a length of 3. here's something that we have to get used to. Okay, when you slice an array, they're views. Okay, and so kind of. Do you remember that dictionary view object and how it updated automatically and all of that? The slice of the array works in the same way. They're not copies. So here I'm going to make this thing z. Okay, and so I'm going to create use slicing to say I just want kind of this corner 0, 1, 4, 5, and I'm going to modify this first element to be 99. Okay, and so when I ask what is this corner array here, it's now updated here. Okay, so this is it's considered a view object. So doing slicing it like this just kind of keeps like a little pinned view of the top corner of the array. And so modifying the original array will also modify the slice. Okay, this doesn't create a copy. If I create a new thing, so here I'm creating an entirely new array. Okay, and so now we're creating an entirely new array, and we're assigning it to the name z. So this part might feel even weirder. Okay, and so this z sub is referencing this array. Okay, this array that happens to be called z. So if I say what is z, z looks like this. But here I'm redefining an entire new array. This is not modifying. This is not a modification where I just change one of the values in here. This is I'm calling the whole new array object, creating a new thing and reshaping it. And so this creates an entire new thing. And so when I call z sub, when I ask what is z sub, it's still pointing to this thing that exists in memory, but I don't have really a way to access it anymore because I've lost kind of the name handle. So this thing still points to this, and this is now an entire new separate object, if that even makes sense. The way Python works is that you're creating these objects in memory, and then your name points to this object, and so when you refer to the name, it pulls back this thing. And so if you use some kind of method that modifies this thing, this name will pull back the modified object. This command over here, however, doesn't modify this object. It just redefines a brand new object, and it takes this name that used to point over here, and it points over to here. Okay, and so the name points to the object in memory, the brand new object. So, but this name still points to the view object at the old place. Okay, if you want copies and not view objects, you can call the copy thing, and so that will work just fine. And then I guess we're running out of time. Concatenate is kind of like your C bind and R bind, except you define the axes upon which to concatenate. I guess we'll have to continue this on Wednesday. Okay. All right. We'll see you guys then.